I'll put that for the second Zoom workshop. People who I'll emphasize familiar with. Sorry, now I have to go find that link. So what kinds of things were people, were there things that people specifically wanted to bring up or discuss or talk to other people? Otherwise, we're just going to vote, I guess. And we didn't really have a bunch of stuff prepared for this because I know there's so many topics in the community that people want to talk to us about and want to talk to each other. And I thought that this would be a nice space to have available for that while we have people here for the workshop anyway. Will?
Yeah, thanks. I have a question that might be a conversation starter. I don't know. So we know that there's this deadline coming up for the end of December to get metrics encoded into MAF. But it's also the case that I think some metrics tend to be expressed in terms of a figure or a vector or something. Mm-hmm. Is there any sort of guidance on what's needed by December? Is it the case, for example, that only scalar maths metrics are what are needed by December, or does it not divide that cleanly?
Yeah, no, I love this question. And it leads into a whole question. Like we have been dealing with some pull requests where people are submitting metrics that are, okay, here I made this figure and it evaluates how well a particular opsim does. And it's really complicated. There's lots of detail and that's great. In terms of evaluating survey strategy from like, is this one run better than another? It's really hard to interpret, right? If there is a whole figure, then it basically needs an expert to tell us like, well, was this run actually better than another, right? At some level. So I think this is where you're seeing some push from us and from the SCOC in terms of like, can you turn it into a figure of merit, like just a number? And that is also hard, and it probably doesn't capture all of your science either, right? So, so there's a little bit of tension there. There's also the fact that, yeah, the SCOC said for the end of December. I think that was tied to when they're coming out with their phase 2 report, or sorry, their phase 1 report. Keep in mind, all the simulations we just released now are things that are going into their phase 2 report. And at the end of their phase 2 report, they're saying, here's what we want you to do for the V3 baseline. So it's a little bit, honestly, I think it's a little bit hard to say. I would say, yes, hey, December, if you want to make any influence, you know, if you want to change their mind on the phase 1 recommendations, you need to have it in by December, probably like fairly, you know, ahead of time in December, since they're supposed to finalize their recommendations in December. But that's it. That's not the end of the road, because they still have this phase 2 report to go through. It's just, you know, at each step, all the options are narrowing down. So if you have something that you think would change their phase 1 recommendations, about, you know, where the footprint should be, things like that, on a detailed, on a like same scale as the phase 1 report, I would say get it in now. Now I know Rachel is probably sitting there saying, oh, but you know, we're working on the footprint and evaluating where the details of the galactic plane coverage should be. We haven't even simulated exactly what I think maybe is one of the options that we need to do so that Rachel can evaluate that for some of the Milky Way stuff. So that, I think that's a level of, the broad strokes are there in the phase 1 recommendations, the details that they need to put in terms of like, okay, how should the detailed coverage of the galactic plane, for example, this bulge coverage, should it actually also have extra islands of fields stretching out at, you know, high stellar density points, like is one of the suggestions. And that I think is certainly something that can fit into the phase 2 report. It's like sort of it's a tweak on this higher level result. Obviously, we're not going to get an answer on rolling cadence to go into the phase 1 report, because people are still, looking at it. We're setting up this task force. I think, though, when I say December is really important, especially if you want to make an impact on what's going into phase 1, that the second cutoff, I would say, is in February. I think it'll be about February. We're going to have these 2.1 simulations responding to what people are saying about 2.0. And so we need to make those simulations. We need to figure out what's going to go into them. So in a way, the December deadline is also good for that. I guess what I'm saying is maybe you should have it in as soon as possible. But there's always still chance to change things, but just on smaller scales. So yeah, try to do. Now, as far as whether it should be a plot or whether it should be a number, if you're having trouble taking it from a plot to a number, I'd say, come and talk to us, maybe, or talk to somebody outside on the SEOC, or somebody maybe a little bit more outside your main science area. Because I think what happens a lot of the time is we get caught up in, this is why this is really good. These are all of the things that you can do with this output and this metric. And we can evaluate all the great science that we can do. But if we're looking at okay, that's really cool, how much better is this other survey strategy than that one? You maybe don't need quite as much detail, and you can, what I would say is you run your more complicated metric on both of them. You see what changed, and with your expert eyes, you say, okay, so I see that this part of my metric, if you're, for example, one of the things I've been trying to help with is a metric that looks at the periodic star modulation, and it's run at a variety of distance modulus, a variety of timescales. And that's a lot of information. So you get a lot of information about a particular run. You say, oh, look, I can see how far away I can see things. I can see how I'm sensitive to particular timescales. But then that's really hard to say if I give you a different run, which one is better. So that's when, as an expert, you kind of have to go sit down and say, okay, so these are the parts of the field that are really interesting, like this particular distance modulus and this particular timescale maybe. And what I want to compare is the area that I get a certain level, fraction of objects detected. And that might be one way to say, okay, and now that's how I think this survey is better than this other survey. And if you have other aspects that are important too, but also for very close things, I want to make sure my completeness is really high.
Rachel,
So then,
what's up with Rachel?
Yeah, sorry.
No, not at all. That was really interesting. And going back to what you were saying about it's valuable to have a figure of merit that and somebody outside the field and the SCOC can evaluate. I completely get why that's important. But I'm also hearing a lot of feedback from people in the community who, I agree, can't see the wood for the trees a lot of the time. They're so deeply embedded in their own field that they really struggle to interpret the results without the detailed output. So is it okay if we encourage them to say, create a figure of merit, something very simplistic if need be for the SCOC, and also produce the more detailed output in the event that that is what they need to help them understand the results?
Oh, I think that's fine. I think that if producing the more detailed results means that the whole thing is going to take 12 hours to run for each simulation, then we might have some issues with it. But yeah, making more output, but telling us how you can simplify it to something that we can more easily compare between runs is great.
Yeah. I think a good example of this is we have a lot of metrics where it is doing complicated things, and you don't have to reduce it to one number. We can do multiple numbers because, for example, the supernovae is like the supernova metric says the number of supernovae and the mean redshift. And so it's like, okay, that's 2 numbers. Or, for micro lensing events, we can just break it into bins and say, fast ones, medium ones, long ones. So, and for solar system
that was
objects,
one of my next questions, because
Yeah,
I've done
and-
exactly that.
exactly. And for solar system objects, we've got, different detection criteria. So, if you have something big and complicated, reducing it to, 2 to 4 numbers is, if that's easier, is a great way to do it, I think.
Yeah, and we do that with the solar system too. The other key part to that though is that if something is more important than something else, it's helpful for us to know about that.
Right, that's fair enough. Thank you.
Jeff, what's up?
I was just going to ask, in the case, just as a practical matter, in the case where, once you've reduced your figure of merit down to, say, a scalar, do you need to actually sort of, in your contributed code, specify like which sort of fiducial to compare that to, or is it always going to be compared to the V2 baseline fiducial, for example?
We'll usually compare it to our default will be to compare it to the baseline, I suspect. But it'd be great. You can say like, here's what the current state of the art is, and so you can have other numbers in there that say like compared to Gaia, here's what it is or something, and so then we would know like, oh, are we doing better than historical results, worse than historical results, or something like that.
I'm not sure. For some of the previous 1.5 and 1.7 simulations, we did have sets of simulations where we compared to something other than the baseline when we were looking at survey strategy within a particular family. Is that the kind of thing you were asking about though, or was it not that?
No, I'm perfectly fine just comparing to the baseline. I just wanted to make sure as a like practical matter when writing the code, do I need to specify that, or is it just code that calculates some metric and the comparison to some baseline will be done later?
Yeah, no, usually the metrics they come out with a number and we run it on all of the different runs. And then we have the number from the baseline and we have the number from this particular run, so.
Great, thanks.
Yeah, well.
I confess I've gotten a bit confused over the different discussions today and yesterday, but for the phase 1 feedback by December 15th or whatever the SCOC's deadline is, which simulations are they expecting input on? Is it all the ones that are available at this point, so including baseline 2? Which sets of simulations are we being expected to comment on?
You know what? I'm gonna pass this to Colin because we have our own SCOC member here. If he's here. Hey, Colin.
Sorry, I missed Will's question.
Oh, sorry. It's also, yeah, there's a lot of stuff. Will was wondering what the SCOC was expecting people to comment on by December, which simulations. And I wanted to ask for you to address that, because my impression was that the phase 1 recommendations is what's going to be released in December. And the phase 1 recommendations are based on the 1.x series of simulations. And so I had kind of thought that the 2.0 simulations were what people would comment on, in spring, essentially. And that they would go into, plus the 2.1, which is like tweaks in response to 2.0, would go into what is the phase 2 recommendations, which result in the V3 baseline. But I could be mistaken. because it is a little fuzzy to me, so.
Yeah, sorry, I don't have that laid out in front of me, and so I don't want to make statements on the fly about that because I'm likely to get it wrong. So let's find some way to get that written down in a text format that we can kind of all agree on, rather than just kind of passing it through Zoom.
Okay.
Yeah, thank you very much. One of the reasons I'm asking is because quite a lot of the community metrics that have been run as notebooks that now need conversion into maybe a condensed form. People have been running those on version 1.71 throughout this year, whereas the version 2 was relatively recently released. So I think a relevant question to people that are working on metrics is going to be, how much processing time do we expect? Or is it just a question of running on existing metrics already? And how much of the work have we already done? So I'm really interested to find out the answer to that question. So thank you very much.
So, well, one thing I would take out of this though is that the recommendations, the thing that will be finalized in December is the phase 1 recommendations. And a lot of there are only some of the simulations that we did with the phase 2 out, this V2 simulation are really directly sort of tied to the phase 2 recommendations, I guess. So yeah, I don't know actually. Knut's on the SEOC too and has his hand up. So let's hear what he has to say.
Yeah, I mean, I think the phase 1 recommendation summary that Jelko sort of gave yesterday, right, was driven by evaluation of the cadence notes and MAF runs on the pre 2.0 simulations. But and so these simulations that you all have produced are in a sense they show where the recommendations are going. Now, if it turns out that I don't think this is the case, right? But if it turns out that the recommendations are really bad for some science in some way that we didn't anticipate, it's good to know, right? At any point, and particularly soon, reasons for that, and so that would mean, if somebody has run their metrics on the 2.0 set of simulations, and discovers something really bad, that would be good to know. If it confirms that this is going in the right direction, then that's that's nice, right? I guess I would say also that there's no requirement to run on 2.0. I mean, the phase 1 recommendations really were based on analysis of 1.7, right? But if you're working on metrics now, I would say why not run it on 2.0 as well?
So that's a very helpful answer, and that's certainly consistent with the sort of turn by turn in the conversation, right? Like the cadence notes were pre-phase 1, now phase 1 is a response to that, and now the response to phase 1 would then be the response to the updates. So am I correct, Knut, that a reaction of the form that baseline version 2 is better for our science than baseline version 1.7, for example? Is that the kind of thing that would be useful?
It certainly wouldn't. It wouldn't hurt, right? I mean, it means that we're moving in the right direction.
Okay.
Yeah, and I think that's always good to know, to verify that we are indeed going in the right direction. So I'm violating Colin's principle of consensus and having something written down and just saying what I think. But
Yeah, I kind of feel like it would be helpful to understand some of these timelines a little bit better. But yeah, basically, if you're, I guess it's a related question would be, what would be required to get to, if people are, do you have this capability to just run a notebook on all of the new simulations? What would be required to just have them just do that? I mean, obviously it would be better to get it into MAF, better to get it into our framework where we can just run it all the time. But assuming that like there's a couple of things that are blocking that, you know, partly being me and Peter's time to help people with that if that's necessary. Yeah, what is the other blockers on that?
I would point out that the directives we've heard at this meeting so far were quite categorical, that stuff needs to be inserted into MAF to be considered by the SCOC.
That is true. I shouldn't go against that. we do want that, like, for sure, right? Because that way we can understand what is actually being run. We can have a look at it. It's you know, one of the fundamentals of writing code is that code review is useful. And when you submit code to MAF, you have somebody else looking at what it is and what you've done. So there's just like, even at that sort of super basic level, there's that too.
So I see Rachel has a hand. I do have a reaction, Rachel. You don't mind waiting for just a few seconds? Okay. So I'm trying to get a handle on whether it's more useful for people who may have a science area that has no metric to work on the science area that has no metric, or if it's the case that if there's already a notebook that needs some work to condense it down into a scalar that would be incorporated into MAF for those pages, which would be more useful.
Okay, so I would say for the second part of that problem where they have a notebook that's hard to condense down to MAF to a single number, the easiest way for them to make progress on that is to talk to somebody else. And I think that a lot of people are reluctant to do that or don't do it. But I do think that just talking to somebody else, even if it's me and Peter, that's, you know, we're happy to help. If it's somebody else, you know, just even a little bit further outside the field, I think that's where it's helpful. And I think they'll make a lot of progress much more quickly than just trying to think about how to work on it. And then as far as like science areas that don't have any metric at all, if it's a science area that sounds like one of the things we've said, oh, we don't have any metrics about that. I don't know. I mean, at that point they have to weigh, like decide is which one of these things that they have is closer to the areas that we're talking about not having any metrics for and being worried about how to choose. That might be another thing. Rachel?
Going back to what Will was saying, I think it would be really valuable to have not just clear guidance from the SCOC as to what they want and when, but make a deadline. But I know they're trying to give us, the community, as much flexibility as possible and not be draconian about it. But the more vagueness you give people, the more it gets pushed to the bottom of the stack, because there's always something more urgent. And you really have to set a deadline and say, thou shalt do this by now. You just need to get traction. I've been trying to be draconian with TVS just to get people going, not because it's coming from the SCOC.
I think that's where the December deadline came from. But yeah, I get what you're saying, and it's difficult, right? Because you're like, yes, do it by then, and if you don't do it by then do it by this other time, because
right.
And
so I completely get it, but I think if you don't, because so few of us are actually paid to do any of this, if you don't, it won't happen. So I think some firm deadlines is going to be a help.
Perhaps they can link it to saying, if you want recommendations that go into this report, it's this deadline. If you want recommendations that are on whatever is left over to decide, it's this other deadline. I don't know.
Yeah, that's a way of doing it for sure.
Yeah, just because functionally, I think tomorrow I'm going to start working on V2.1 and, the deep drilling fields and things. And so obviously I'm not going to be able, because we just released 2.0, I'm not going to get a lot of feedback on that to incorporate in 2.1. So I think it's, the next big deadline is going to be for the final decisions that go into V3, which is supposed to be the operations one. So you should get your V2 feedback in as soon as possible. If it gets in quick, I might be able to incorporate it, but there is still one more deadline to be done before then.
Speaking of the 2.1, you should send me the how you wanted your proposal for reconfiguring the galactic plane coverage, Rachel.
Sure. What would you like it? I've got I've got notebooks. What sort of form did you
Yeah,
want?
wait, what was the change? I know you wanted to add these Whitefest deep level fields that were basically single pointings.
Yeah.
And we'll do our best to incorporate that. We're not entirely sure how exactly it will work having Whitefest deep level fields in the middle of everything that are isolated like that. And if we want to handle them as deep drilling fields, or if we want to, because they're isolated and you probably don't want, there's dithering issues with treating them just as pure Whitefest deep level fields. So.
Right. I know we talked about that when we spoke directly about it. I'm kind of agnostic. If you want to treat it as a dithered pointing, that's fine. That would only actually improve things for us. The real motivation would be just to reduce the size of the area that's being prioritized for the whole galactic plane, because I get that that's likely not what we're going to get. So it's in a sense just making sure that more of the time is not just centrally condensed over the bulge, but also along the galactic plane as well, which is something that I think was not quite in the current baseline 2.0.
Okay. Yeah, okay. So if you send us, I guess the major thing being like add these pointings that you pulled out. And then I think you had, we'll look at what the time, the extra time that requires, and then we'll reduce the bulge coverage itself accordingly. But if you tell us, like, was it that you wanted to make it shorter or narrower, or shorter is easier, just in terms of like, there was some push to make everything connected. So, and I think that there's good reasons for that. So if we make that bulge region, instead of making it, it's kind of like an outcropping like this, instead of making it narrower, it's easier to make it shorter. But that might
shorter in L or shorter in B?
Longitude.
Okay. I think that makes sense from what I've seen of the priority areas.
Okay.
I think it makes sense to abbreviate it in longitude, but then distribute some of those fields further along the galactic plane. Okay. If that's viable. I mean, if it turns out for whatever reason that's not possible, then it would be really interesting to know that.
Okay. And I know you had spent some time picking out those pointings. So I guess that's probably the easiest thing, is if you just send us where those are, then we'll figure out how to put that into the footprint.
Okay. So as a list of RS index or a FITS map, or
a list of RS index is fine, right?
Okay.
Either one would work, but yeah. Okay. Sorry. But that's a great advanced topic. There you go.
And that would be a good one to slip in 2.1. If anyone has any footprint experiments they want to do, fiddling the footprint is one of the easiest experiments we can do. So we can slam out lots of those rapidly. And there's no reason to hyper tune it to say like, oh, we just want a little bit here. We can just run 5 different ones. And if some of them break, we say, okay, that's too much. And it's compute time is cheap. So it's usually faster to just run a bunch of simulations and say, okay, that one works best.
Yeah, the part of that particular change that makes it a little bit more difficult is because we have to decide like what's the best way to treat those extra fields. So
Sure.
we'll probably try a thing or two.
I think I have an idea of the simple way to do it. Because the issue we're discussing is because by default we try to do contiguous areas of sky just to keep the slew time down and solve a traveling salesman problem. So so if we have these isolated fields,
I see.
it'll break it. What it'll try to do, it'll say, oh, that's my maximum, and it'll try to make a contiguous region around that. But so it'll end up overexposing the region around it. And so currently there's a toggle switch that says force the growth to be contiguous or just do greedy and allow it to do that. So the simple thing to do is just add a free parameter that says like, oh, if your maxima are incredibly separated, don't force contiguous. Whereas if it's smooth enough, go ahead and force contiguous. And we can just compute both and say like, oh, if the difference in total reward is more than 20%, break off and go contiguous. And that way the slew time penalty will be minimal.
Okay.
So because at some point we switched from, just take all the maximum in the reward map, and I turned it on and said, force it to be contiguous. And I got like 1.5% improvement. And so we're like, great, that's the new default, but now we can make it so that we can go either way.
Thank you. I hadn't appreciated that was going to be a problem, but I can see how the algorithm would tend to do that.
Right,
So if that's not too invasive a change, then I'd really appreciate it.
Yeah. And then the deep drilling fields, we just treat completely separately. And because they only execute on average once per night, it's not worth optimizing, because on average, it's like, oh, we spend 1 minute of slewing per night out of 8 hours is not a worthwhile thing to try to optimize out.
Right. That's fair enough. Okay, that makes a lot more sense. And we're fairly flexible on exactly the pointings, and whether they're dithered is mostly fine. I don't think that's going to have a significant impact on what we're proposing. So there's a lot of flexibility there. It's just a question of spreading more of that area that's currently concentrated very much in the bulge a little bit more along the galactic plane.
Yeah. And that should be easy.
The dithering part was, I was worried that it was making it more expensive than anticipated. Because you have this time that you haven't accounted for that is not contributing in the same way. An easy way to think about it is like that it might be twice as expensive as you anticipate, because you, instead of just looking at the one field or the one pointing, you're looking at 2 pointings next to each other. But we'll have a look at that too.
And I'm not sure I've looked at the most recent thing. How do we have, are we evenly, is the subscription pretty even across RAs? Because we've increased the bulge, but for a long time we were undersubscribed at that region. So I'm not sure how worried we should even be about adding more time there.
One experiment I did want to do is basically diff the two maps and compare which areas are getting sampled at the rate that we were hoping for versus which areas are not. That's been on my to-do list for a while.
And I'm curious if people will like rolling in the bulge, because we did the extreme 6-band rolling and I did a 2-band rolling. It's just cutting the bulge in half. And I am curious. I think some people might really like half rolling in the bulge.
That has a lot of potential for quite a lot of science. There's certain complexities to how it's done. For example, the static science, I think you need to sample it regularly throughout the 10 years to make sure you get some of those areas of science. It would be great to coordinate that with Roman as well. So it depends when exactly you do the rolling cadence versus when the gaps are and how long the gaps are. But it has a lot of potential for a lot of time domain stuff, yes.
Can I just throw in one thing back on the dithering for 1 second? Just to clarify the issue, so that so we can get a clear proposal here. It's not just about, one can think of it as how expensive your pointing is, because you have to account for extra area to get the number of visits you want in your target area. But also you can think of it as if you only did a certain number of visits aiming for your target point RA and deck, but they happen to be dithered so much that you ended up getting a lower effective number of visits for most of the area in that 10 square degrees, because some of the visits are a little bit out, some of them are out this way. We really like to know, do you really want this number of visits in like exactly that footprint? Or is it acceptable to go to the lower number of visits because they got kind of dithered around?
That's an interesting trade-off. And mostly we want numbers of visits on individual light curves because but we also want more stars. There's some of the static science would benefit from just having sheer more stars over more area in different parts of the galaxy. So that it's a non-trivial trade-off, but it kind of depends on how big the dithers are. So if they're so big that the entire field of view is effectively duplicated, there's no overlap whatsoever, then yes, you're just halving the number of visits you do per star, in which case it could be more detrimental than positive. If it's a 10% shift and most of your stars get the high cadence, and then you get a lower cadence but on more objects, then that's probably a win. But there's obviously a break-even point at some point.
Right. So so that parameter is sort of up for you to tell us what's the amount of dithering that would make sense for this type of field. We got that feedback for the deep drilling fields, where people specifically, the point of deep drilling fields is a lot of visits, so they don't want giant dithers that would be detrimental to that. So it sounds like this is also in that kind of similar regime as the deep drilling fields, but it would be good to like have that sort of stated specifically.
Okay, thank you. I can get some specific advice on that is more than my intuitive feel.
Okay, I will say we don't currently dither to different amounts in different parts of the sky. And I'm sure we could hack something that we could do that, but I'm not sure that's the best approach. Otherwise, it would be to flip over and treat these like deep drilling fields and more separate, but which is part of the other part of the consideration, right? We might do that.
There
So
is
what
different amount.
is the dithering at the moment?
So it depends. For the deep drilling fields, they're individually set. So they can, I think they're dithering like a ½ degree. And then the Euclid fields are doing their own unique thing because it's a double field. For everywhere else, we do not have fixed fields. We have a fixed tessellation that we randomize the orientation of every night. So it's pretty extreme. So for these pointings along the galactic plane, we might as well you can make them arbitrary size. And some nights it could be one field, one pointing. Some nights it'll be 2. Some nights it might even be 3 that'll cover it. So it's kind of arbitrary if we treat them as part of the generic footprint.
And do you have I guess it's hard to frame the right question, I guess. Do you have a way of calculating what the average overlap between pointings is, between sequential pointings?
But you mean between neighboring pointings?
Yeah.
Yeah, it's fixed, and there are actually some triple points too. Like sometimes you get a triple. I don't know off the top of my head.
Well, it used to be on the order of 10% when we were using circular fields. So I suspect it's I don't know what it is when you start treating the fields properly with the camera geometry.
And that's 10% in area, presumably.
Well, like I said, it was 10% when you're looking at circles of fields, and then the circles of fields, when you look at this overall tessellation, overlap by
Yeah.
sort of about 10%. Like I
Okay.
said, we don't actually have circles on the sky. But then we also have vignetting, and the idea was with the circles was that, you more or less washes out. And I guess we haven't actually looked at this with the camera geometry. We probably should.
Hmm.
I don't know. I don't know the answer. It will be at least a few percent, but I don't think that's not actually the cool. I think what you were, the part that I was wondering about is how much extra time do you need due to the fact that your underlying tessellation doesn't always align with your field, and that's not quite the same question.
No.
And so the tessellation is it's just basically, it's spun every night, right? So it's not going to end up in the same place, and it could be it could be half a field of view off because you're spinning it randomly. So
Right. Yeah, I
Which
guess
is
I'm
why
trying
I
to figure
think-
out how to take this into account now, because
Yeah.
it's quite difficult to say you're not pointing at a specific point in the sky and saying, well, it was 20% off the RAN deck that I indicated. How do you evaluate what the overlap for a given field will be? I guess at the end of the day, it comes down to numbers of stars and numbers of visits per star.
You can look at the edges of the footprint, and if you look at how the roll off of number of visits happens there, that's essentially what would happen, right? Because when the edges of the footprint and the number of visits we get near the edges of the footprint are, it is essentially showing you that roll off, that what that spinning of the tessellation will do. Because on there's nothing else to go and visit on the other side.
That makes sense. How do I get to the number of visits based on where they are in the footprint? Is it just the XY position of the star? Is that available in the results?
Wait, what?
I guess I'm trying to figure out. Usually I look at the number of visits statistics that are calculated presumably as an average of the field. How do I get at the number of visits per star as a function of where it is on the CCD?
So if you drop the per CCD, the number of visits per visits per star on the sky is the number of visits metric that we calculate.
Right.
Right. If you add, I want to know which CCD this star fell into in each observation, that is something we don't actually calculate currently. Our field of view map just tells you like if it's on silicon or not. And we don't come back with the actual CCD number.
Okay, I guess I'm trying to get to how do I check for a star that is close to the edge of the field of view.
That is yeah, sorry, Colin.
It's not, I don't think the field of view is what you're interested in here. I think
Right,
you're talking
yeah.
about your target area on the sky.
Yeah.
So we're using field of view as like what chip on the camera, but you're talking on the sky. And so I think really what we're looking for here is an experiment from the simulation. If you selected a 10 square degree area and gave it a high cadence in a sea of lower cadence, what would the like roll off of effective number of visits be as you went from the center of that 10 square degree area to 2 times that? But I think that's information that we would need from the simulations. I think I take the point that it's basically the same roll off as the edges of the wide, fast, deep, but I think it'd be clearer to just do that experiment and know what the answer is.
And I suspect what our answer is going to be is the larger you make your area, the more efficient it is going to be, because if you can imagine making it just a single heel pixel that we're saying, okay, I just want to observe that single heel pixel, it's everything around it will be roll off. Whereas if you make it a fairly large blob, it will be your area to roll off area ratio will be higher. So,
Yeah. And you could see this when I was trying to calculate the time it took to turn those area and number of visit into survey effective time or into survey time. You could see this effect there too, because some places were some footprints were just more expensive to actually simulate in terms of the survey time. That said, I think, Colin, it's not an unreasonable point. We could probably run a simulation that just does this like single point, like here, let's choose a small region and let's like a deep drilling field or something essentially, and just look at like what happens when you wide fast deep dither or, just our normal observing, like if you just had that one point on the sky. And then we'll just, stop the simulation after you get 800 visits or so. I think that would be pretty quick. You would obviously not have realistic distribution of weather and sky or whatever, but it would just show you what the coverage would look like. And another thing we could do is just look at the edge of the wide fast deep and like just plot that roll off. And I think that explaining that how to do that we can do, but it's also maybe easier for us to just do these other experiments and let you know.
I think that might be a really useful plot to have so that we understand it as generally, and I'm sure you can produce it faster than I can. But it also occurs to me one option we have is to maybe have fewer but larger pencil beams. Because I picked a number of 20 at random and just went, well, I wonder where those arrive, and optimized them, and then took it to the community and went, so does this seem like a good idea? And they went, yes. And that is the extent of the optimization that's been done in that direction.
Yeah.
So we could do larger pencil beams, and we could maybe be a little more careful about where we place them if it makes the whole thing more efficient. I guess the thing we need to figure out is where's the sweet spot, and how do we figure out where the sweet spot is?
Right. It's worth keeping in mind when like one of the early simulations for the new baseline, we did have this line, that thin line covering the galactic plane. It was basically one field of view wide in the target map. But obviously we can't observe just one field of view wide when you include the idea of dithering. And so there's some examples like from that you can just sort of see what happens, that it does get fairly expensive and you do have these roll-off effects. So when you're thinking about transforming the few pointings into a more consolidated set, because Peter's right, it's basically the larger your area and the fewer edge, the lower the ratio of the edge to the area, this will be more efficient. And so when you're making these new pencil beams, if you make them very thin, like one field of view wide, you still have the same problem.
Yes. Okay. So clusters of pencil beams makes more sense. Will, are you still on the line?
I'm still here, yes.
So it seems like there's going to be specific areas which would be more important than others that we could put a cluster of pencil beams on. Now, we've got some of that information based on the stuff I cribbed from the white papers already. And there's going to be things like star forming regions. And we should point them, for microlensing, we want to point through as many galactic arms as possible. So there's another avenue of optimization we could consider. What else jumps out at you?
It would be good to have some coverage of negative longitudes of the bulbs just to probe both sides of the structure.
Yeah.
I don't have more of a quantitative response than that on that subtopic. There might be fields that have particular clusters of interest in the inner Milky Way that could be useful to visit. More specific than that, I'd probably need to go back to the cadence notes to lift some more information. As you're well aware, of course, there's also the synergies with external data sets like Roman and Euclid that should probably receive some observations, but I don't think we know yet where they're going to be.
Well, we do more or less for because there's limit. It can be part of the set. I think the knowledge is a good point. My impression is that that's going to be footprint probably takes both of those into account, but I need to check. Star formation, globular clusters, the star forming regions are already in the footprint. The globular clusters are already in the footprint. I haven't checked where the pencil beam clusters are relative to lines of sight through the galactic arms. I think that's something to check. There
might be areas in which interstellar medium characterization could be particularly important. I don't know if we have any of our ISM experts on the call right now, but there may be particular regions that would be particularly valuable to constrain. So that might be another, and that might be sort of, opposite to where you want to look for microlensing, because you care about having as many stars as possible, whereas the ISM might be the opposite. If there are regions that have, are as extincted as possible.
And that might actually be it might be the anti-science driver too, because most of the science cases I've looked at have been optimizing the number of stars included, so we've minimized the extinction. I don't know, but thank you. I think that's given me some ideas of where I can more productively optimize the pencil beams.
Yeah, and we can interact outside this meeting as well. So I'd be happy to help where I can. And just parenthetically, I love the phrase anti-science case.
Yeah. Okay. I'll ping you after the meeting then. Thanks, Will.
Great.
Meg has her hand up.
I wanted to ask a general question, sort of wearing my SCOC member hat on, is what do people need between now and December to get these metrics in? Because I think there's going to be a lot of internal, and maybe again, Colin and others who are on here can agree or disagree with me. I think we're going to be doing a lot of evaluating things that come up in discussion. We might need a mini simulation to check something here. And so having all the metrics in are going to be helpful for us to be able to do this without going back to every community and asking you to do this effort. What is it you need between now and, I guess, December, or if we say January 1st, to get in and finalize the metrics you're developing? I think Peter and Lynne have done a really great job of all the different avenues that they've made available, but I just want to make sure if there's been, things that have come up in this session, what else do you need or potentially need from your friendly SCOC science collaboration liaisons to help you get to the finish line? That we can take back out of this meeting so that we can make action items on.
I think the first thing would be more hours in the day. I think that's what a lot of people are struggling with at the moment. There's just a lot of people have a lot of other stuff going on that they are obliged to do. It's certainly been an issue for me, but I can ask the question.
That's a great question. It's one of the questions which will be asked to participants at the missing metrics session a little later on this morning, evening, whatever we are now. But just sort of one impression I've had from the feedback I've received is that just that process of converting the metrics people have done in notebook form, so going backwards to make it into something that can be ingested into MAF. I think that's a fairly large hurdle that people are working to overcome. And it might be that that's such an individual thing. It may depend completely on the individual metrics people are doing. So that might be a question of the authors interacting with the simulations team to get over that hurdle. At least in galactic science, we have a lot of cases where there's a cadence note and there's a notebook which may have proprietary data or something else that's not in MAF.
Yeah.
I think the fusion of that into what MAF needs is I think a big issue.
Well, can I ask you, can we, offline afterwards or whatever, can you send me a list of where, I know there's the metrics and the Excel spreadsheet, but when I look at that Excel spreadsheet, it's still not clear what is actually, here is a thing that people have actually calculated in a notebook that is something that they could actually turn into something for math. In other words, I guess there's a lot of variety. So if you have a list of like, okay, these people I think are actually pretty close, or, have some, this is something that I think is really important. If you can send me like, let's start with like 2 or 3. If you're like, these people are close, let's get that converted into math. That would be helpful. I think that way it also adds some priority in like what you think are the important cases. So maybe that's a place we can start with that too.
So I think that sounds really good. We've added a couple of columns to the spreadsheet you're mentioning, the metric packages spreadsheet, at least in the case of new metrics or new metric packages, for people to just write, what do you want to calculate, which metrics would go into that. But if you have input on sort of, precisely what information you would need to help make that determination, that would be very helpful for us, like to know what we need to tell you, like what that information would be. I mean, maybe like even a 1 to 10 of how close is it to completion.
Okay.
Something
It's
like
really
that.
hard to tell that if they don't have any link to code. So if they have, you say they have a notebook, if that notebook is online, can you put the link to that notebook in the metrics?
Links and
That'd be
notebook. Okay.
I think it's worth at this point clarifying that I went through the metric spreadsheet on the individual metrics page, and I have linked all of the notebooks and all of the documentation that I know of. So the links to there should be in that spreadsheet. But I think it's probably worth starting with the metric packages tab, because that's the one certainly from TVS that we've been updating. And that one has more up-to-date documentation from our side, at least.
Meg.
Just a suggestion on this. Is it worth encouraging people that have notebooks at this point, because they're going to have to communicate back and forth, that maybe the message needs to be, if you want this done, you now need to come forward. And like, if you don't start talking to, or there's not a representative from you talking to Peter and Lynne and their team, like this is not going to happen. And that if you're okay with that, because I know in Solar System, we had people like, I'm going to write a metric, and I'm like, really? And then there was no metric put in because it's hard, right? And then it was also realized that although it wasn't perfect, there was some other metric that sort of did what you wanted, but it wasn't perfect, but you could use it. And we got a lot of people that were like, okay, we can live with this thing. And so I don't know if that will happen for the other science areas. They're still working on some metrics. But maybe that's a good way of saying, like, if you think this is absolutely important and it's not now covered by something else that's in there, you need to go to these office hours, right? Or like you need to you need to make sure you send an email or go onto Sims MAF and contact, the team. So that maybe it's that way. So that way might make it easier, so that Peter and Lynne aren't sort of going through and looking at all this code and then where are they sending an email to, and make it that way. I know that puts a burden on the community, but maybe that also makes it a little bit easier that there's direct conversations with the relevant people who might have time now, or somebody else within that team might be stepping up to now be that communication link. I don't know what people think, but that was just coming up for me.
I think I quite like that idea, and I'm conscious that a lot of the community are struggling with just to get it done in time. I know they're feeling the time crunch. So I think maybe it would be helpful. There's quite a lot of people who are sort of most of the way there who want to finish this and want to contribute, and maybe getting them to say, I am still working on it. I do want to wait, hold the horses, I do want to contribute this, as opposed to the people who we haven't heard from since they wrote a white paper in 2018, for example. It's,
Yeah.
I think might be a good thing to do.
I also, it would be helpful from our point of view also if there is some indication of like priority. I mean, and I guess that's where the metric packages come in, like, because you haven't put something in the metric packages if you don't actually think it's important. I think, right? Because we do get people coming to us with sort of, okay, here's my niche science that perhaps you shouldn't actually determine the survey strategy on, but here's my metric, can you help me finish it? And it's hard to tell from, if it's not an area that we're very familiar with, it's hard to tell, you know, with our limited time, if we don't have time to help everyone, who do we help first? And if I'm going to the notebooks and I just look through, I'm going to send to the people who are, it's like, oh, this is very close, you just need to change this or this. I'm going to start with those. And the people who have like cleaner Python, it's easier to read, so I'm going to be able to get through that first, you know, things like that. There are a couple of people recently who've come in and been like, here's my notebook, here's my metric, please add it to MAF. And it's not actually in the right like API. Luckily, both of those people, I haven't gone through the return, like one of those people I sent that to and it came back and it's in the right format, we can run it. And now I'm just like, okay, but how do I actually set it up so it runs and you have useful information? But another person, you know, I haven't actually looked at their result yet. So there will still be some contribution that needs to happen from them most of the time. And that's another step where if I could just go and talk to people and nobody replies, it's going to slow down. So that's another place where if there's something that you know, like this is really important and it weighs in on the survey strategy and the parts where we're like, what do we do with the dusty plane? And that might not be obvious to us, right? So the prioritization is helpful too. We have about 10 minutes left. We didn't end up splitting into multiple breakouts, but I think this was actually really interesting for me, and it's helpful to see what parts people are still, you know, having problems with, or what, you know, where we need to spend a bit more effort. Are there other areas that people wanted to bring up or talk about?
I guess the other thing I can throw out is that, you know, I also have several metrics floating around in notebooks that should be converted. So we could have a metric finalizing group or something where I, you know, because it is useful to have other people look at the code. So I might, you know, we could just have a group where every other week or something, I'll hop on Zoom and be working on my metrics. And if other people have notebooks that they want to hack on, they can bump up the priority. But if people want to look at my notebooks and show their own notebooks, we could have a try to merge things in.
Great idea.
I think I've currently got a surface brightness metric that's floating around, a shape metric that's floating around, and that could also be converted into a star galaxy separation metric. We could yeah. And if everybody's busy, I'll just sit on Zoom alone and work on my notebooks. But if other people come in, we can work on their notebooks too.
And those are all really useful metrics.
Right, and they're all metrics that people have requested and that I've started on and haven't gotten over the hump yet. So
when you say surface brightness metric, is this for point source surface brightness equivalents or unresolved?
For large low surface brightness kind of thing. So kind of you know, if you had basically tidal streams, like a 10 by 10 arc second tidal stream, would you reach a surface brightness limit where you could say, yes, there's a stream there or not.
Yeah, Jeff Carlin, who I've been corresponding with over Slack, he and I worked on mostly him developed low surface brightness dwarfs and resolved tidal streams in the galaxy for cadence notes, and I think we'd like to turn those notebooks into metrics.
Wait, was yours the cadence note that said it was be like surface brightness limits of 30?
No, it was a different. It was somebody else. Yeah,
That was somebody else. Okay.
No, it was actually.
Oh,
Because in resolved stars you can get, I mean, we'll probably get to like 34 in the Milky Way. You can get to crazy low surface brightnesses if you can pick out specific tracers in individual resolved stars.
Mm-hmm. Okay. It's actually a different one than the one Lynn's thinking of. There was another one that said for unresolved sources you could get down that low, and I think we tracked it down. There was a bug where we have 825 visits in the wide fast deep area, and they assumed that was per filter, not summed over all filters. And so there was a factor of 6, and when you do square root of 6, it's a factor of 2.5, which is exactly 1 magnitude. And so we figured out like I'm getting 1 magnitude shallower, and it was like, oh, it's that factor of 6.
and we've seen that mistake has been propagated somewhere else now, and I don't know.
Unfortunately, it went on the pH, and now people are citing it, saying like, oh, Ruben will reach these levels, and so we're backtracking, trying to say like, no, please don't cite that, and don't let this claim snowball, because if everyone thinks we're going to get that deep, that folks will be disappointed. So,
well, the Galaxy Science Collaboration would be extremely interested in seeing your surface brightness metric that you were talking about implemented.
Excellent.
Yeah, that was hopefully that's going to be a tech note of some kind.
Yeah, I had to spend a day doing the signal to noise algebra for and finally gave up and like, okay, surface, source limited, read noise limited, sky limited, and I think I finally got it right. But
I wonder if we need to have a look at like this other, or if it would be useful to try and get this other aspect of low surface brightness into a metric or not.
We can add it to the queue. It sounds like we've got a lot that we should put in the queue here and get the ones that are in notebooks over the hump.
If Jeff has some time to spend on it, maybe.
I've been working on it while we're chatting. I forked the repo and started writing or converting my notebook code into real code. So hopefully soon we'll have something.
Perfect. Do you have you seen the notebook on writing a metric? There's a tutorial that Eric Nielsen put together, and might be helpful if you have any questions about the API, but you may not, so you may already be past that.
Yeah, I was sort of looking at that as a reference to make sure I'm, and also like it has nice examples of how to test your algorithms as you're going. So yeah, it's very helpful. Thanks.
Okay. All right. Well, I think today was useful for us. We have like 2 minutes. If there's any last minute concerns. All right, cool. Yeah, I think that's a great idea to set up like some sort of remote pair coding, essentially, hack sessions, and sounds good. We'll do that. All right.
Thank you very much for holding this session. It's been really helpful to have all your input.
Yeah, I second that. Thank you very much.
Good. Yeah, I mean, it's always helpful if you can get like a couple people who are trying to talk about the same thing in the same place, and so I appreciate you all coming, and thank you. And then there's community sessions in about 15 minutes, I think, starting for the back on the main Zoom. I think we can hang up here and I'll see you all in 15 minutes. Thank you.
Bye, everyone. I'm the host, so I think you'll get booted out here if you don't leave on your own. You don't have to go home, but you can't stay here. Yeah.